In this podcast, we're going to be learning about angles. So first, adjacent angles. So adjacent angles are two angles that share a vertex, share a side, but do not overlap. And you have all of this in your notes, as well as all of my little helpful hints here. All right, so we have 4 examples here of adjacent and non-adjacent angles. So in the first one, angle 1 and angle 2, those are adjacent angles. So angle 1 and angle 2, notice they share a side. The side that they share is, well, it's not labeled with any points here, but it's where the blue and the green lines overlap, where I have written down the side. So right there, oops, that's the side they share. You can see vertex, point B is the vertex that they share. Right? So those are adjacent angles. Angle 1 and angle ABC would not be adjacent angles. So you can see where angle 1 is, that's outlined in red. This would be angle ABC. So notice they would overlap. Right? So they would not be adjacent angles. So even though they would share a side and share a vertex, because they overlap, they would not be adjacent angles. Right? And if we look below, here we have 2 angles. Those are adjacent angles. We have angle A and angle B. So that red line there, that's the side they share. They share the vertex. So angle A and angle B are adjacent angles. In the next diagram, angle A and angle B share a side. They share that red side there, but that's all they share. They don't share a vertex. So notice that the vertex for angle A is over here, and the vertex for angle B is over here. They're not the same, right? So because they don't have the same vertex, they're not adjacent angles, right? So it's not enough just to share a side and be next to one another. You have to share the vertex, right? Otherwise, they're not adjacent. And then last of all, we have our 4th example. That's also not adjacent angles either. So there we have angle A and angle B. The one that's outlined in blue is angle A. The one that's outlined in green is angle B. They share the vertex, but they don't share a side, right? So you have to share a side and a vertex, right? And not overlap. All 3 things have to be true for you to be adjacent angles. Right? So that's going to be, adjacent angles is something we're going to be working with, and some properties apply if angles are adjacent. And we're going to be working with those after we talk a little bit about another kind of angle, and those are vertical angles. Right, so in this diagram, we have 2 straight lines, lines A and line B. And so those labels there, those are just the lines. We just labeled it with an A and a B. Points A and B. This is point A. It's not labeled well because it's way off the picture there. And point B. All right, so that's line AB. And then we have line CD. So there's point C, way off the labels right off the picture, but we'll just put it right there. And then line CD there. And they overlap. They intersect. And they intersect at point E. Right? And so when we have 2 lines that intersect, we have 4 angles that are created. Right? We have angles 1, 2, 3, and one more that I just erased, 4. Right? 4 angles are created. And when that happens, we have some special angles that are called vertical angles. Right? So vertical angles are angles that share a vertex. They're formed by 2 intersecting lines, and they're opposite one another. So angles 1 and angle 3 are vertical angles. Angle 2 and angle 4 are also vertical angles. And there's something special about vertical angles. Right, so the angles are called vertical angles because they share the same vertex. So that's an easy way to remember it. Vertical, vertex. In this example, we have one more example. A and B are vertical angles. So in your notes, you already have this picture and you have the 3 important things. I don't think you have the numbers next to it. So in your notes, I want you to write the numbers of the 4 important things that define vertical angles. So vertical angles are number 1, formed by intersecting lines. Number 2, share a vertex. And number 3 are opposite one another. All 3 things have to happen together to make those vertical angles. Right? So on the right-hand side over here, Angles A and B are vertical angles, right? And there's the vertex that they share. It's that point of intersection for those two lines. Angle 1 and angle 3, and angles 2 and angle 4 are vertical angles, right? Here's the vertex that they share. They're formed by two intersecting lines. They're opposite one another. Now, angle 1 and angle 2, and angle 2 and angle 3, and angle 3 and angle 4, and angle 4 and angle 1, those are not vertical angles, right? Those are adjacent angles because they are next to one another. They share a vertex. They share a side. They don't overlap, right? So 1 and 2, 2 and 3, those are adjacent. The ones opposite, 1 and 3 and 2 and 4, those are vertical. All right, so in the diagram above, angles 1 and 3 and angles 2 and 4 are pairs of vertical angles because they form an X. Then they're opposite angles in that X. They share a vertex and they're formed by intersecting lines. Okay, so you have that information already in your notes. And I think on this page there's a fill-in for you. Right? So at the top there, we have vertical angles are, so we had all the other information in your notes already, except for these pictures that are also now in your notes, but you have to fill in the blank there. Vertical angles are congruent. So that's something special about them. So their definition is that they're formed by intersecting lines, they share a vertex, and they're opposite one another. There's something special is that they're congruent. So in the picture to the right, angles 2 and angle 4, angle 1 and angle 3 are congruent because they are vertical angles. So whenever we say that angles are congruent, we want to say why. Whenever we say something in geometry, we're going to say why. And so the reason that they're congruent is that they're vertical angles. And we know vertical angles will always be congruent. In the picture, they're also marked as being congruent. When you have rounded marks, in that figure there on the right-hand side, that second figure, if they have the same number of rounded marks, that means they're congruent to one another. So all the angles with one mark are congruent or equal to one another, and likewise, all the angles with 2 marks are going to be congruent. In the picture on the left-hand side, we can see the angle measures are written in, and you can see those opposite angles are congruent. So the ones written in red, they're both 75 degrees, they're congruent to one another. The ones written in green, they're 105 degrees, they're both congruent to one another. Right? So we've learned now about adjacent angles and vertical angles. We're actually going to learn about 2 more kinds of angles. And coming up is our next type of angle we're going to learn about, and that is supplementary angles. So 2 angles are supplementary if they add up to 180 degrees. One of the supplementary angles is said to be the supplement of the other. So supplement just means you're the angle that if you add to me, we're going to be 180 together. So here, these 2 angles, the 139 and the 41 degree angles, they're supplementary because they add up to 180 degrees. So nothing else has to be true about these angles except that they add to 180 degrees. So since 139 plus 41 is 180 degrees, right? Together, those angles are supplementary. If we push the 2 angles together, notice they make a straight angle, right? Because a straight angle has 180 degrees, right? So together, if we put them together, we have a straight angle. And our last type of angle we're going to learn about in this podcast are linear pairs of angles. So linear pair of angle is a type of supplementary angle. They are a pair, and they're also a type of adjacent angle. So they are a pair of adjacent angles formed by intersecting lines, and they're called linear pair angles. So in the following pictures, angle 1 and 2, and angles 2 and 4, and angles 3 and 4, and angle 1 and 3 are linear pairs. And you have everything in your notes. So the special thing about a linear pair angle is if you look at them, notice that the 2 adjacent angles formed by those intersecting lines like 1 and 2 and 2 and 4 and 4 and 3 and 3 and 1, together they make a straight line. And we know that a straight line is equal to 180 degrees. Therefore, a linear pair of angles are always supplementary because together they equal 180 degrees. So angle 1 plus angle 2 is 180 degrees. And angle 2 plus angle 4 is 180 degrees. and angle 3 plus angle 4 is 180 degrees, and angle 1 plus angle 3 is 180 degrees. So any of these that we add up that are next to one another, that are formed by those two intersecting lines, they're going to add up to 180 degrees. And if you look at them, you can see they form a straight angle. So it's easy to remember what they add to. I'm just going to move my little check marks. And I took away some of my arc. All right, so the arcs there, they show angles are congruent. So the angle 2 and angle 3 are congruent to one another because they're vertical angles. Angle 1 and angle 4 are congruent to one another because they're vertical angles as well. So when we have two intersecting lines, we're always going to have two kinds of relationships. We're going to have two pairs of vertical angles, and they're going to be congruent to one another. And we're going to have four pairs of linear pair angles, and they're going to be supplementary to one another. So it's really easy to work with these angles because either they're congruent to one another because they're vertical, or they add up to 180 degrees because they're a linear pair. So linear pair versus supplementary angles. And I have this in your notes as well, and it is a fill-in. So a pair of supplementary angles equals 180 degrees, and the measure of a pair of linear pair angles equals 180 degrees. What's the difference between a linear pair of angles and supplementary angles? Well, here's your fill-in for you. So supplementary angles do not have to be adjacent. Right? So supplementary angles are any two angles at all that add up to 180 degrees. They don't have to be adjacent to one another. They could be in two separate rooms. It wouldn't matter, as long as they added up to 180 degrees. But a linear pair of angles are always adjacent. Right? So a fill-in there, we know that a straight line is equal to 180 degrees. I think that was from the last slide. So just fill that in on the first blank. I think it came right from, actually I'll go back to the actual sentence. A straight line is equal to 180 degrees. I'm sorry, the fill-ins were on this page, not the other page. So here was your first fill-in, 180 degrees, fill in that in your notes. And then always supplementary is the second fill-in for the linear pair. Sorry, the fill-ins were on this page. This is right above it, right below it, and it is already in your notes filled in for you. And it's filled in that supplementary angles do not have to be adjacent, but linear pair, they're always adjacent. So because it measures of the two angles in the linear pair of angles are equal to 180 degrees, you can still find an unknown measure the same way as you find unknown measures with supplementary angles. Right? They add to 180 degrees. It's just that linear pair also have to be adjacent to one another. So speaking of that, let's find the measures of some angles. And I have all of this in your notes. All right, so the first one is kind of on the right-hand side there, and the second one there is at the bottom of your notes. And this is going to fill in the whole first page of your notes. All right, so we want to use the figure at the right. Given one angle measure, we're going to find the other three. All right, so we're going to find the measure of angle PMO. PMO. So that one is right here, PMO. We want that angle measure. Well, I know that these two are adjacent angles. And they're not just adjacent angles, they're linear pair angles, right? Because they're formed by two intersecting lines. So together, angle NMO plus angle PMO, we're going to add up to 180 degrees. So I'm going to write it like this. So angle PMO is just going to be equal to 180 degrees minus angle NMO. And we know the measure of angle NMO because it's in the diagram. So that's just going to be 180 minus 125, which is 55 degrees. So that's all there is to it. If you know one angle and you want to know the measure of the other angle in the linear pair, you just have to subtract from 180. The measure of angle PMQ, that angle is right here. Notice it's a vertical angle to the angle that we're given, angle NMO, right? The share vertex, they're formed by intersecting lines, and they're opposite one another. So if angle NMO is 125, so is angle PMQ. So we don't have to do any work there. 125 degrees. And then lastly, angle QMN. So that's the angle right here. Now you have two ways to find that. You can either find that as part of a linear pair, or you can just remember that it's vertical angles with angle, what we already found, angle PMO. So since angle PMO is 55 degrees, so is angle QMN. And let's actually write that in. So it's a vertical angle, and it's going to be congruent. We'll just write what is shorthand. It's just those two angles are congruent because they're vertical angles. So we can just write in that angle PMO is congruent to angle QMN. And likewise, let's add this part in too. Angle PMQ is congruent to angle NMO. Right, so that's how we knew those were, what those measures were. They were just vertical angles, right? And so we just knew they were congruent. Let's do the bottom part here. Now, the one thing is these angle measures, they're going to keep changing, right? So notice that we have the measure of, in one is, so here's an angle 7 and an angle 7, right? So in one problem it's 47 degrees, and one it's 15. So each problem is just a separate problem. We're just using that diagram to help us find the measures of the angles. Right, so if the measure of angle 6 is 78 degrees, then find the measure of angle 7. Right, well, together they have to add to 180 degrees. Right? They're a linear pair. You can see they're forming a straight line. So that's going to be equal to 180 minus 78 degrees. So that's going to be 102 degrees. Now I'm going to erase this, because now we have a new set of angle measures. The measure of angle 8 is 94 degrees. Find the measure of angle 6. Well, those are vertical angles. So if angle 8 is 94, angle 6 is 94 because they're vertical angles. Now let's find the measure of angle 8. We're given the measure of angle 9. That's 124 degrees. And we want this one. Right? Well, together they form a linear pair. They form a straight angle. So angle 8 is going to be equal to 180 degrees minus 124. So that's going to be 56 degrees. See how easy these are? Either they're congruent or they add up to 180. And that's always going to be the relationship when you have angles formed by two intersecting lines. So we're looking for the measure of angle 9. Angle 7 is 47 degrees. Angle 9 and angle 7 are vertical angles. So angle 9 is also 47 degrees. Moving right along. Measure of angle 8 is 158 degrees. We want to find the measure of angle 9. Together, they form a linear pair. Right? They have to add to 180, they form a straight angle. So all we have to do is take 180 minus 58, and we get 22 degrees. And last but not least, so none of these angles aren't drawn to scale, obviously, but they show the relationship as to whether they're a linear pair or vertical. And that's all we need. The measure of angle 7 is 15 degrees. We want to find the measure of angle 6. Right? Well, together, they're adjacent angles formed by intersecting lines. Right? They are a linear pair. Together they make a straight angle. So, if we simply subtract 15 from 180, we have the measure of our angle, which is going to be 165 degrees. Right? So if we have two angles, they are formed by intersecting lines and are opposite one another and share a vertex, like angles 6 and angle 8, they're going to be congruent. So those are vertical angles. If you are two angles formed by intersecting lines and you are adjacent to one another, like angles 6 and angle 7, you're going to add to 180 degrees because you are a linear pair. Okay, and that's the big idea for this lesson, knowing the difference between vertical angles and their relationship, and knowing how to work with linear pair angles and knowing their relationship. Thanks for watching. Bye for now.